Hi everybody, in this video we will wrap things up for the different algebraic things you can do to evaluate limits. And what better time to rekindle our love and affection for trigonometric identities. So let's just right off the bat start this one. We can try evaluating this. We can try direct substitution. The cosine of 0, of course. By the way, we're working in radians, as always. The cosine of 0 degrees is 1. And the sine of 0 degree, or 0 radians, I said degrees, I apologize for that, is 0. So we get our 0 over 0, which means we can do something about this whole thing. Removable discontinuity, all that good stuff. So what are we doing here? We want to manipulate this thing somehow. Been a long time, but how can I get sines and cosines playing together? We remember that sine squared plus cosine squared is equal to 1. That's the Pythagorean identity. How can I make this thing into a sine squared? Well, let's, I don't know, multiply by sine over sine. Because remember, we can manipulate things all we want, but we have to do the same thing on top and bottom. So now I have 1 minus cosine x times sine over sine squared. Well, so what? Well, remember that sine squared is equal to 1 minus cosine squared. So that might be fun and exciting. So let's try it. 1 minus cosine on top times sine over, let's get rid of the sine squared and write it as 1 minus cosine squared. Very, very tempting to cancel the squares here, but absolutely not. Under no circumstances should you ever do that, because what actually happens is this thing factors into 1 plus cosine times 1 minus cosine. Remember, difference of two perfect squares. X squared minus 9 is equal to x plus 3 times x minus 3. A squared minus b squared is a plus ba minus b. Well, 1 squared minus cosine squared is 1 plus cosine, 1 minus cosine. So what? Well, so what is this? Now we have a cosine, 1 minus cosine on top and bottom, on numerator and denominator, to divide each other out. So what we now have is a different function. Let's see if the limit as x approaches 0 is any more interesting in this situation. What's the sine of 0? Well, the sine of 0 is 0. What is the cosine of 0? Well, the cosine of 0 is still 0. How does that differ? Well, now we get 0 over 1, which is 0. Hooray, we did all this work just to prove that the limit of this thing is 0. For anybody still listening, I would like to point out that both of these things are equivalent to each other. You can show that on a graph, as always. Remember, this thing is going to be undefined at 0. But this one is not. Even though they look the same, that one plugs the hole. Let's look at one more trigonometric identity, or trigonometric graph, and analyze what's going on with the limit. In this particular one, we're just going to start with the graph and just take a look. Now, I said before we have to deal with radians. In this particular one, we're still dealing with radians. This one gets really weird in degrees. Don't worry about degrees. When you graph this thing, make sure you do it in radians, do it in Desmos, do it in your TI-84. However, you should get something like this. What happens as x approaches 0? As x approaches 0, what happens to the output? The output approaches 1. So don't overthink it. Sometimes all you need to do is graph it and check out what's going on.